Hello everyone, here is a problem from Cambridge textbook A level. In the first part it says state the two conditions necessary for an object to be in equilibrium. So for an object to be in equilibrium we need two conditions to be satisfied. The first condition is the sum of all forces towards x-axis and the sum of all forces towards y-axis must be equal to 0, both. Right? This is the first condition. And the second condition is that the sigma torque, all torques around the pivot must be also equal to 0. Under these two conditions, we say an object is in equilibrium when these two conditions are satisfied. Okay? So part B is explaining about this figure, which a disc is attached to a rod with the length of 50 centimeter and the radius of this disc is 24 centimeter. And there are two forces acting on this rod in opposite direction, which both of them create a moment of force, which is or a torque, which is a torque of a couple, the torque of a couple. So both of them, they create clockwise torque with respect to the middle of this disc, which is the pivot point. Okay, so therefore the torque here with respect to the middle point of the rod will be equal to one force, which is 30 Newton times the whole length of the rod, and that is 30 Newton times 90 centimeter, which will be equal to 27 Newton meters. Okay, 27 Newton meters. And on the other hand, we see there is a rope attached to the disc, which prevents this disc from rotating. That means this disc is in equilibrium, as the problem says. The rope attached to the edge of the disc to prevent rotation. All right, so that means this rope must create a torque which is in opposite direction to the torque of a couple created by these two forces, 30 newtons. So this is clockwise, and the other one, torque created by T, which is anti-clockwise, we take it as negative. Okay, and we say torque sub T. Let's say sub T. That means it's a torque created by the tension force in this rope will be equal to the radius which the disc has times the tension force, which will be equal to tension force times 0.24 meters. Okay, but since this disc is in equilibrium, that means it does not rotate. The sum of these two torques must be equal to 0, the second condition of equilibrium. So we say sigma torque around this pivot must be equal to 0. Therefore this was negative, forgot to write the negative, T times 0.24. So therefore it will be equal to negative T times 0.24 meters plus 27 Newton meters, right? This must be equal to 0. So that means 27 Newton meters must be equal to 0.24 meter times T, which T here will be equal to 100 12.5 Newton, and that is the answer, tension force in this rope. Alright, thanks for watching, and please like and subscribe to this channel. Thank you.